suppose that if you have the function x to the power y plus y to the power x equals to 1. Now if this is the function which is given to you, this is somewhat like an implicit function. In case if this function is given to you, how will you differentiate this? Okay, so the best way to go about this is just go on differentiating this. Okay, so what will you have is you can just assume this, that this is u plus v equals to 1. Okay, and u is basically x to the power y and v is y to the power x. Okay, so what is log of u is log of x to the power y, which is y log x. This is log of u. Differentiating this, you'll be getting 1 by u du by dx is first function as it is into derivative of second function plus second function as it is into derivative of first function is, what is the derivative of y with respect to x? dy by dx. Okay, so du by dx is equal to u into y by x plus log x dy by dx. In place of u, what you can write? You can write x to the power y, okay, by x plus log x dy by dx. This is your du by dx. Okay, now let's look at this v. So again, taking up the derivatives, what you will have, log of v equals to log of y to the power x, differentiate, and again you can also write this as log of v equals x log of y. So differentiating this, what you will be getting is 1 by v dv by dx is equal to first function as it is into derivative of second function is 1 by y into derivative of y is dy by dx plus second function as it is into derivative of first function is 1. So dv by dx could be written as v into x by y dy by dx plus log of y. Okay, so dv by dx, in place of v, what you can write is y to the power x into x to the power y dy by dx plus log of y. Okay, now what you can write is that du by dx, and this will be so in case if you take up the entire thing, so du by dx plus dv by dx, and differentiating 1 with respect to x is 0. Okay, so you will just substitute this here, both of these which you have just calculated. In place of du by dx you will write this, you will just write this. So just doing this, which is this plus this one, this one here, this will give you equal to 0. Okay, I've done nothing. I've just substituted du by dx which I've found and dv by dx which I've found and substituted in that equation. So simplifying this, you'll get x to the power y by x plus x to the power y log of x dy by dx plus y to the power x into x dy by dx plus y to the power x log of y would be equal to 0. So what you will have is, just taking all the like terms of dy by dx together. So it'll be x to the power y log x plus x into y to the power x dy by dx is equal to, taking all the terms without dy by dx on the other side of the equation, which you have minus y to the power x log of y minus x to the power y x by y. Okay, so you can write dy by dx as, minus y to the power x log of y minus x to the power y x by y divided by x to the power y log of x plus x into y to the power x. You can further simplify this, but you can leave this here also. So this is one of the example when you have sort of an implicit function. Okay, let us look at one more example. Suppose you have the function, you have an equation like sine y to the power x plus cos x to the power 1 by y equals to 1. Suppose you have this function. Okay, this is an equation, you have to differentiate this. So what you can write is that you can write this as u plus v equals to 1. U is sine y to the power x and v is cos x to the power 1 by y. So you can write du by dx plus dv by dx, and differentiating 1 with respect to x is 0. So your u is sine y to the power x. Log of u is log of sine y to the power x. You can write this as x log of sine y. Okay, this is log of u. Further simplifying, differentiating this, you'll be getting 1 by u du by dx is equal to first function as it is. This is the first function, and this one is the second function. Into derivative of second function is 1 upon sine y. Into derivative of sine y is cos of y. Into derivative of y is dy by dx. Plus second function as it is, that is log of sine y, into derivative of first function is 1. So what you will have is x cos y upon sine y is cot y into dy by dx plus log of sine y into u. In place of u, into u. In place of u, what you can write? Sine y to the power x. This is what you can write. This is du by dx. Then what about v? V is, even I forgot it, cos x to the power 1 by y. Cos x to the power 1 by y. So log of v is log of cos x to the power 1 by y, which could be written as 1 by y log of cos x. Okay, so this is first function, this is the second function, and you will have 1 by v dv by dx is equal to first function as it is, into derivative of second function is 1 upon cos x, into derivative of cos x is minus sin x, plus second function as it is, into derivative of first function is minus 1 upon y square, and derivative of y is dy by dx. Okay, So what is dv by dx? Is v into 1 by y, or rather minus 1 by y tan x, minus 1 upon y square log of cos x dy by dx. Okay, in place of v, what you can do is that you can substitute this v which you have just assumed, which is cos x to the power 1 by y. Okay, now the expression is du by dx plus dv by dx, so you'll just substitute it. So this is the expression for du by dx. Okay, so just taking it here. Okay, this is du by dx, and this one is dv by dx. Okay, this one, and all of this would be equal to 0. I've just substituted the two expressions here, nothing else. Okay, just taking up all the like terms together, which is x cot y sin y to the power x dy by dx plus log sin y into sin y to the power x, and this will be minus, I guess, here. Yeah, so it'll be minus cos x to the power 1 by y into 1 by y into tan x minus cos x to the power 1 by y into 1 upon y square log of cos x dy by dx equals to 0. So this is what you have. So taking all the like terms together, what you will have is x cot of y sin of y to the power x, okay, minus 1 upon y square cos x to the power 1 by y into log of cos x, all of this into dy by dx. I've taken all the terms of dy by dx together, and all the other terms going to the other sides, without dy by dx will be going to the other side, which is 1 upon y cos x to the power 1 by y tan x, and this term going side will become negative. It will be minus log of sin y into sin of y to the power x. Okay, so dy by dx would be equal to, this is the numerator which you will have, this is the numerator which you will have here, and this one is going to be the denominator. Fine, and this is your dy by dx in this case. I'm just rubbing this. Okay, so this is dy by dx in this case. Okay, so these are some of these are just two simple example of sort of an implicit differentiation and logarithmic differentiation at the same time.